One of the advantages of inverses is that if we're given a matrix equation, sometimes we're able to solve for an unknown matrix by applying the inverse. So for example, if we have an equation that looks like this, and we're interested in solving for the matrix X, we can apply the inverse on both sides and solve for X. Now you have to be really careful when using matrix inverses. The order of the multiplication matters. So if A begins on the left side of X, A inverse ends up on the left side of B. And that's because of this intermediate equation that I haven't written down. What happens when we have A inverse and A beside each other is that we get the identity matrix. And we've already seen that the identity matrix times X is just going to give us X. And similarly, if we begin with an equation that looks like this and we're interested in solving for X, we can apply A inverse on the right-hand side to remove the A. And just like before, A times A inverse is going to give us an identity matrix, and X times the identity matrix is going to be just X. So let's go ahead and try to solve a matrix equation. If I would like to find the unknown matrix X, what I can do is I can multiply both sides of this equation on the left by the inverse of this matrix if it exists. So what we have to do first is we have to calculate AD minus BC for this matrix. We have that A times D is 3 and B times C is 2. So we get a final value of 1. We know that this inverse exists. So the 2-2 formula tells us that the inverse of this matrix is going to be 1 over AD minus BC. We'll switch the order of the numbers on the main diagonal, and we'll change the sign of the other two numbers. So the inverse of the matrix that we're looking for is this one. So what we would do is then multiply both sides on the left by that inverse matrix that we just calculated. These two matrices are inverses of each other, so when we multiply them, we're going to get a 2x2 identity matrix. And of course, you can go ahead and you can check that that's true on your own. What we're interested is multiplying these two matrices together over on the right-hand side. And when we do perform the multiplications on the right, this is the matrix that we obtain. And the final step is we know that the identity matrix times any matrix is going to equal itself, and this allows us to isolate for X. So X must be equal to this 2x2 matrix here. So a couple words of advice at the end of this video, and the first one is when you are multiplying by inverses, make sure that you're really careful about the order. There's nothing more frustrating than getting a test back and you losing several marks because you've ended up switching the order of your multiplications. And the second note is kind of interesting. It goes along with this new extension that we have for powers. Now that we have both positive, negative, and the 0th power, we have usual rules for exponents. So for example, if we have a to the power of k times a to the power of L, this is really equal to a to the power of k plus L. Or if we have a to the power of k, all raised to the power of L, this is equal to a to the k times L. So your usual laws of exponents will work for matrices now. Alright, my little epsilons, stay positive.